Good morning, students. Welcome to your channel Scores 27. I am the Pratibha. So today's question is, which of the following has no conjugate base? Is this H2PO4 minus, which is also called as dihydrogen phosphate, H2PO2 minus, which is also called as hydrogen phosphide, H2PO3 minus, which is also called as dihydrogen phosphide, and CH3COOH, which is also called as acetic acid, right? So the question is, which of the following has no conjugate base? Let's analyze one by one. We will analyze option number 4 first, that is CH3COOH. CH3COOH. This is acetic acid. Now, as you are all aware of, a conjugate base is formed when an acid it loses a proton. Proton, that is H plus, right? An acid loses a proton. For example, here it is acetic acid. This acetic acid can lose a proton, that is H plus, to form CH3C double bond O minus, that is acetate ion. Acetate ion, which is its conjugate base. So here we can analyze that acetic acid loses a proton to form an acetate ion, which is its conjugate base. So yes, acetic acid has a conjugate base. Now let's analyze the first one, H2PO4 minus. H2PO4 minus, right? To analyze this, let's first draw the structure of H2PO4 minus, that is dihydrogen phosphate. P double bond O, single bond O connected to hydrogen, right? So we have 1 2 3 4 4 oxygen and 2 hydrogen connected to oxygen. So this becomes H2PO4 minus. Now here we can notice that this H2PO4 minus, it loses a proton, right, and forms H2PO4 minus, which can further lose a proton, right, to form PO4 3 minus, that is its conjugate base. This is again the conjugate base of H2PO4 minus, right? So again this H2PO4 minus also has its conjugate base. Now let's analyze the second one, that is H2PO2 minus. H2PO2 minus, which is also known as hypophosphite ion or phosphonate or hypophosphorus acid or hydrogen phosphide, right? Let's first draw the structure of H2PO2 minus, right? Let's first draw the structure of H2PO2 minus. P double bond O, right? Single bond O over here, and this hydrogen is directly attached to phosphorus, right? This hydrogen is directly attached to phosphorus instead of hydrogen being attached to oxygen, right? This hydrogen is directly attached to phosphorus. Hence, you know that when an hydrogen is attached to an oxygen, there is a difference in electronegativity, right? So the oxygen electronegativity is almost 3 and hydrogen is 2.1, right? Because of this, the electron pair share between oxygen and hydrogen is more pulled towards oxygen, leading to partial positive charge on hydrogen. That is, more is the magnitude of partial positive charge on hydrogen, right? And more it is acidic. It is just like a political party within the ruling alliance, which is getting less opportunities and the power being pulled by the largest party. So what happens? The alliance weakens, the proton gets released and a conjugate base is formed. But this is not the case of H2PO2 minus. Why? The hydrogen is not attached to oxygen. The hydrogen is attached directly to phosphorus. Both the hydrogen is attached directly to the phosphorus. As you know that the electronegativity of phosphorus is around 2.09 and hydrogen is 2.1, resulting in a more stronger bonding. And because of this stronger bonding, it is very difficult to release this hydrogen atoms. Hence, no H plus is released. No H plus is released and no conjugate base is formed. No conjugate base is formed. Right? So the correct answer is H2PO2 minus, that is hydrogen phosphide. This is the right answer. There is no conjugate base is formed, as we can notice from the structure that the hydrogen atom is directly bonded to the phosphorus atom. Hydrogen is not bonded to oxygen, right? As a result, there is no H plus which has been released and no conjugate base is formed. Now let's analyze also one more option over here, H2PO3 minus, right? Which is also known as dihydrogen phosphide, H2PO3 minus. So let's first draw the structure of H2PO3 minus. P double bond O, single bond H, single bond O, H, and this one is O minus, right? So we can see over here that the hydrogen is attached to the oxygen. As we can already see that there is a difference in the electronegativity. There is a difference in the electronegativity. Hence this hydrogen release is possible, minus H plus and HPO3 minus. The conjugate base is possible. Conjugate bases possible. Why? Because there is a one hydrogen is directly bonded to oxygen, right? And one hydrogen is bonded to phosphorus. Now this hydrogen can be easily released. Why? Because there is a difference in the electronegativity between oxygen and hydrogen, right? The oxygen electronegativity is around 3 and hydrogen electronegativity is around 2.1. Hence, because of this, the electron pair shared between oxygen and hydrogen, it is more pulled towards oxygen, leading to a partial positive charge on hydrogen and a partial negative charge towards oxygen. It is just like a political party within the ruling alliance, right? Which is getting hydrogen getting less opportunities than oxygen. and the power is being pulled by the oxygen, and this hydrogen gets released and he finds himself some other party, right? So this hydrogen minus H plus and a conjugate base is formed, that is H2PO3 minus. So we can see over here that dihydrogen phosphate, dihydrogen phosphite and acetic acid conjugate base are possible, but the conjugate base is not possible for H2PO2 minus, that is hydrogen phosphide, because here the hydrogen is directly bonded to the phosphorus atom. Okay, so the correct answer is H2PO2 minus. Thank you. If you like the explanation, please subscribe. Thank you.